Hello everyone. Last time we discussed what are the basic concepts with respect to AI, ML, and data mining techniques. So we talked about X to Y association. We will be having input parameters as X and we will be predicting or finding the value of Y. So we had training data, we had testing data, and we had results. So whenever you're talking about any type of data mining technique, you will be talking about X to Y association. X will be your input parameter. It might be 10 parameters, it might be 15 parameters, and how those parameters are working together to give our result as Y. That is what your algorithm is all about, and that is what your data mining is all about. How you're mining the data to find that association. So that is the source of true information, because it will be connecting your data together to give rise to information, because earlier it was just random data, right? And once it is connected together, then it becomes information, then it becomes intelligence. So that is what the goal of data mining techniques is. And what we discussed was that we will be having input data, and that input data can be your historic use cases like 20 years back or 40 years back of data, that collection of data. Using that data we use a model, and that model is going to use any data mining technique or algorithm or some processing functions from any software. That model will then predict or find out how the associations are working. Once the model says that I know how to find out the result, then we give in some testing data to find out if the model is working or not, right? To find out the accuracy of the model, to find out what is the actual correctness of our data, what is the error between our prediction and the true result. And depending upon that, we keep on testing our model and we keep on changing our model until we achieve a very good model which has a very good prediction rate. So we had to discuss the steps which are involved in building any type of ML based application, AI based application, or data mining based application. So the first step is to collect the data, right? You need to find out the data, whatever you're working on, whatever use case you're working on, you need to sort out data from different sources, be it your structured sources, be it your unstructured sources, any type of data which is there, you need to collect it. Just keep on collecting the data. Then you have to prepare the input data. You need to cleanse your data, format it, and handle the missing values, because it happens in a lot of cases when we talk about unstructured data and we put it into relational tables. How you are going to handle, in relational tables we have rows and columns. In unstructured data you don't know what type of information will be there. So if you store such type of unstructured data in structured formats, there will be some missing values. How are you going to handle with that, right? So simple little questions which need our attention before we can analyze the data. You need to know how to cleanse your data, you need to know what format you need for analyzing at later stages, and then you prepare your data according to that. Once you prepare your input data, then you go to analyzing that data, right? Once your data is prepared, you said that these are the 10 databases which I am going to process under my application, under my use case. Then you use your algorithms, you use your plotting graphs, you find out what is matching where, you use mathematical equations to find out the mapping, right? Everything is running in numbers, so you need to know about linear algebra and all of those things to find out your algorithms working, how will it work. Once you find out your algorithm, right, to process your input data, then you need to train that program or that algorithm, right? So you find out first of all that these are my input features and this is what I want, and now I am using little operations to find out better how these X and Y are connected. Once you start finding that out, then you will be finalizing yourself on some algorithm that this algorithm needs to run. Once that algorithm is decided, then you will use it over and over to the best possible ability of yours, when you will be like totally satisfied that now I am getting good results, this is the true model which I wanted. So that happens in the training stage. Once you are over this training stage, then you will go into testing stage. And in testing data, you will have a separate mound of testing data, which you will only use for testing. You will not use it for training your program. Once your program is trained, once you say that, my application is ready, then you use test cases to find out how effective it is, right? And once those test cases are run, you need to find out the error margin, how what is the percentage of your prediction correctness, what is the accuracy of your predictions. All of those errors will be worked upon again. You will again train the program and then test the algorithm. So we keep on switching between these two until unless we find what we're looking for. And last is to use it. If the testing is successful, use it with new data for which we need an answer. So this is where we use the future related questions, where we use the current recent data to predict what is going to happen in future, right? And in most of the cases, 70 to 80% of effort goes in first 3 steps, because the data is so much scattered over so many different sources. It becomes difficult to collect and process the data, right? So if you want to work on big data based application or process some type of use case as per your project or anything, just make sure that it will take a lot of time for you to prepare your data. Because if you don't have a very large data set, then your model will not be very efficient. So the more the merrier, right? The more data you have, the better it is for your model to train itself. So that is why when we are processing a very huge data set, when we are accumulating lots and lots of data, and we're cleaning it, we're preparing it for analyzing, we are formatting it, we are handling all of that data, so it takes up a lot of time. How to handle missing values? It is a very major question. How are you going to handle it? Are you going to put 0, or are you going to put the extreme value? How you will do that? So the first option is to delete the entire row having the missing value. Here the take is we will lose the information also, right? If you delete the row which is having some missing values, you will lose the rest of the information as well. The second option is to delete the column which has a lot of missing values, but here also we are going to miss some other value as well, right? So comes the third option, where you will fill the best probability value at that place. And to fill the best probability based value, you need to find out what is the ideal value to be put at the missing places. So that is the third option. Fourth and last one is to find out the average of the entire column and then you put it. Another option again can be to put zeros at the entire place, but then 0 is a very significant number. It might change our results as well. So handling missing data is a big problem, and it comes down to your data, your sheets, and how you want to use that data. Will putting an average value, will it be useful, or putting a 0 will be useful, or deleting the entire rows and columns? What is going to work? You need to find that out and then use it. We can't use text data such as name, course name directly, so we apply some process techniques to use the text data by converting it into numeric equivalent. Talking about the databases, and when once you have stored your data, right? So you have many databases, you have a lot of data, but when you process it, you cannot simply say that let's map name and course together. The system and the algorithm is not going to understand what is the weightage of name, what is the weightage of course, what is the weightage of marks, right? So you need to associate those textual names with some type of weights, with some type of numbers, so that your algorithm is able to understand that what is the value on a scale of 0 to 5, what is the significance of name and what is the significance of number, roll number or course number or marks. So your columns, yeah, so we apply some process technique to use the text data by converting it into numeric equivalent. So this is going to happen when you will be coding your algorithm. When you will reach that stage, you will take input from your database file and you will say that, you know, I am going to apply these 5 operations, and for those 5 operations you will have to map the name of rows. You will have to give some numeric value which you think is right, maybe 1 2 3 4 5, maybe it changes with respect to your technique, right? So again, this is very normal and okay to understand that directly you cannot use textual data to find out the associations. You need to give it some weight or you need to assign it some value before using it for analysis. We don't use the model generated by the machine. So directly whatever you are generating, whatever model you are using, you cannot use it directly which is provided to you. You need to test it over and over. If you are satisfied by the performance, then only you apply it. So in most of the cases it is going to happen that you won't be satisfied in the first time and it takes many turns, maybe 20 times or 40 times. You are training it over and over to come as close as possible to predicting the right value. So that happens again and again. You just don't directly go like, I worked on this, I applied one algorithm and this is the model which I propose. You need to correct it back and back again to make it more comprehensive and to make it more correct, right? Then you launch it and you use it on your future test cases, on your future questions. So that is, I think, all. In the next video we're going to talk about these techniques of machine learning, briefly talk about these techniques so that you get an idea about what is supervised learning, what is unsupervised learning, what do we mean by reinforcement learning. So we will learn about this. Thank you.